So now I will start with the hypothesis test. So we have covered the 7 quality tools which are dependent on Minitab, though there are a couple of more tools which I would cover later because those are theoretical based. And so I am just getting into the hypothesis testing now, and wherein I just want to sort of recap so that you all can remember that what we discussed. Okay. So hypothesis testing is of two types: null hypothesis and alternate hypothesis. Okay, null hypothesis always says X does not have a significant impact on Y, and alternate hypothesis say that X has a significant impact on Y. And how do I check that? That's with the help of p-value. So now I will talk about the different types of tests that we have depending upon the data that I have. So I'm just mentioning it over here. Although it is there on the slide, but I just want to write it here so that you can pay attention to what I'm writing, and so that it makes clear sense out of it. Okay. So this is the test name. This is the type of data. Then we have some prerequisites. Okay. So if my y is continuous and if my x is continuous, okay, y continuous, x continuous. Can someone give me an example of y continuous, x continuous? Any example?
Height and nutrition.
Height and
nutrition.
Nutrition. How do you
Level
measure
of
nutrition?
Vitamin D, let's say. Level
Sorry?
of vitamin D.
Okay. Level of vitamin D could have what sort of options?
So it can have, it can be, milligram per liter.
Okay, great.
And yeah.
Got it, got it. So when you said level, I thought you were talking about high, medium, or low. So that's very, very important. That continuous data is something which we always remember. Okay. So I'm just mentioning what you said. Height. So we all know height is always in centimeters, millimeters, and nutrition levels. Okay. That is also in grams, milligrams, sort of. Okay. Or vitamin levels. So if my y is continuous and my x is continuous, I will do a test called correlation and regression. Correlation and regression is a test that I'll be doing when my y is continuous and your x is continuous. Okay. So for this, there is no other sort of a prerequisite. It's only y continuous, x continuous. It doesn't matter whether your data is normally distributed or not normally distributed. If you have any combination like this, you will do a test called correlation and regression. Okay. So correlation is a different test and regression is a different test. So both gives a different sort of inferences, and we need to do both in that scenario. Okay. When my y is discrete and my x is also discrete, okay, then I will do a test called chi-square. Can anybody give me an example of y discrete and x discrete? Any sort of discretes? I would recommend friends to speak up, no matter whether you are right or wrong.
Accuracy
Please.
percentage, Samar.
Okay. Accuracy percentage, very good. Versus
attribute or attribute.
Could be, so what attribute? Any attribute anybody wants to talk about? I need at least 3 examples of chi-square. Then only I'll proceed further. It's one of the most common tools that we use in Six Sigma. Most common in service industry, and in manufacturing we use. There will be more coming up. but this is one of the most which we use in at least service. So I need more examples. So accuracy versus
Accuracy versus machine type.
machine time.
Machine type, sorry, not time. Machine type.
Okay, sorry, my bad. Machine
Turnaround
time.
time.
You can have
Turnaround
accuracy versus
Turnaround time.
the day of the week.
Very good. What else? Let's think of any other Y now. Both accuracy both हो गया. Think of any other Y. Any other Y discrete.
Number of pizza toppings versus
Number of
number of pizza toppings versus number of pizzas ordered.
Very good. Very good. One more. I'm becoming more greedy now. You're coming up with good examples.
Your X might be, your Y might be SLM met percentage.
So met versus not met, and so I'm just mentioning here Y and here. Yeah, met versus not met, and X can be
Number of customers.
yes, correct. Number of customers. Okay, so if my Y is discrete and X is discrete, any sort of discrete, we have learned nominal, ordinal, percentage, binary, count, any sort of things are there. Then in that case, I would do a test called chi-square. But I have to convert this discrete into category only, okay, which could be machine type. So accuracy में आप कर सकते हो pass fail, defect not defect. Okay, you can always convert because the formula of accuracy would always be defects divided by total opportunities. Okay, so that is what a chi-square is. Okay. Now if my Y is discrete and X is continuous, then I will do a test called binary logistic regression. Binary logistic regression is a test that I'll do if my Y is discrete and X is continuous. Here there is a prerequisite. Y has to be binary. That's why it is called binary logistic. So once again, when my Y is discrete, you're doing a project which has a categorical sort of a data, whether it is yes or no, and your X is continuous. In that case, you will do a hypothesis test called as binary logistic regression. इसको BLR भी कह सकते हैं. So people use it BLR. So any examples? I want 2 examples. Friends, I'm not getting responses from everybody, so I'll be calling names now because this is very important. This is basic that we are covering. When I get into the test, you yourself will face trouble, and then you will not be able to give yourself a good rating by the end of the day. So whatever comes to your mind, we are here to learn. We have invested a lot of time, money, energy. Please speak up. Whatever you think.
Pass fail versus the amount of time spent studying.
Pass versus fail versus
time spent studying.
Time spent. Very good. So Ashwini, you will not say anything now. I will ask others to.
Yeah, got it.
Okay. So I'm just going with serial order. So Mahesh, my friend.
Okay, not okay versus time spent in a quality.
Not fair, Mahesh. You have just copied. Say something else for continuous. Sorry, I'm being a little strict today because I know this has to be understood by everyone. Then only we will learn the hypothesis very well. So okay versus not okay versus any other continuous data. We'll give you 30 seconds to think, Mahesh.